Hi, welcome to my talk about reproducibly capturing code. In this talk, I'll be discussing a little bit about why it's sometimes difficult as a data scientist to share your artifacts, such as notebooks, with other people in a way that they can execute. A lot of it is down to how Python has become sort of the de facto tool for data science, and it's very rapidly evolving. You're always getting new libraries, new versions, new features, and all that sort of dynamic nature means that it's sometimes difficult to have something that you can capture and hand over to someone else and have them execute it in a way that's reproducible. So I'll be talking about one approach that uses a tool called anaconda-project in order to help you manage all this sort of complexity. Now, many people have different approaches. They might use environment YAMLs. They might try and give people or users commands to run. I'll be talking a little bit about all of these, and I'll be actually using a notebook that I've just been talking about in a different talk as an example. So this is a notebook that I did a talk about. It's all about visualization. I recommend that you check it out, where we use a tool called hvplot, and we use it to visualize data about diseases. The details don't matter for this talk, but the key point is this notebook has quite a few dependencies. It's got things like data files that you need to load, and so on and so forth. So the goal is to take a notebook like this and give it to someone else so that they can actually execute it. You want them to hit run all and have the whole thing execute from top to bottom, no import errors, no problems with dependencies, and have a smooth experience. Now, I'll kind of jump to the end and show you where Anaconda-project will take you, and then I'll talk a bit about why reproducibility can be such a problem. So in this notebook, there's this link here, which goes to anaconda.org, and it gives you a download link for something called an Anaconda project. So if you click download, you'll get a file, which is an archive, which I've got here already. And if you just extract this archive, you'll see this little directory. Now, this directory contains the notebook that you're looking at, the one called Reproducibly Capturing Code, as well as the notebook that we want to ship, or the notebook that we want other people to be able to reproduce, which is the Exploring Data notebook, as well as this little data file. So there's also this file called anaconda-project YAML that I'll be talking a lot about, and that's what makes it all a reproducible unit. So how does this work? Jumping straight to the end of this talk, let's say I have a completely new environment, which I create with conda. It's completely empty, just to show that from nothing, I'll be able to reproduce this notebook with very little trouble. So I create an empty environment, I then activate it, and now I just need to do two steps in order to share this with someone else. I just need to tell that person to install Anaconda-project, so they do conda install Anaconda-project, which takes a few seconds. You don't even need to do this in a clean environment. You can do pretty much any environment you already have, so those first steps aren't even necessary. And then all you need to do is, once you're in this little directory, all you need to do is run anaconda-project run. That's it. What you'll see is it'll start making a conda environment for you. It will download all the packages with the right versions, and then it will execute the command that'll launch the notebook so that I can just execute it from top to bottom. And the idea is that this is a reproducible unit of code that can ship to someone else. And it doesn't have to be a notebook. It could be a Flask server, REST API, a dashboard, pretty much anything you can think of that you need to give to someone else in a reproducible manner. So it looks like it's about finished. It's executing the transactions. And as soon as it's done that, it will launch a new tab where I'm working with the Exploring Data notebook. So here's the existing one. And in a second, you should see a new empty version of this notebook. Might not actually be empty, but I'll show you that I can execute it from top to bottom. So here it is. It's started. And if I go back to my terminal, you can see that the notebook servers automatically started running. And now I can start stepping through, and you can see that there's no import errors, there's no trouble. It's all a nice, smooth experience, all the way right to the last cell here. So give it a second to catch up, and that will show you that the whole thing is a reproducible unit. So how do I go about doing this for people? Let's close this one. Well, the first thing we should talk about is a little bit about why reproducibility is such a difficult thing to do. Imagine that you had this notebook, and only the notebook. You find it somewhere online, you're very interested in it, you don't know anything else about it, but you just want to run it. You just get the IP1B file, and then what? Well, you have quite a few steps. Just like what I just did, you might make a new environment to get going. And the first thing you do is create this empty environment, nothing in it except Python. Well, if you want to view the notebook, okay, I guess you could do it online, but if you actually want to run it, you're going to first need to install Jupyter Notebook. So you do conda install Jupyter Notebook. Okay, great. That's nice and easy. Then you can do Jupyter Notebook exploring data IPONB, and that will open it up. And you will have something like this, except it will have no output. It will be completely clear, just like this. Then what happens is you hit the first line, import pandas as PD. Well, you've not installed pandas, have you? You don't have anything. So what you're going to have to do is go through the notebook and think of all the different packages that you might need, all the different imports that are necessary to make this notebook run. So you just look for the import statements. Okay, import pandas, import numpy, something called hrplot, which is really the point of the whole notebook here. Something called holoviews, and then you have imports of xarray, and that's about it. So you've gone through the notebook, you've kind of scanned it by eye, and you've seen that there's a whole bunch of imports. And in fact, there's some tools you can download that automatically give you this list of imports, but I'm going to talk about that here. So you might then go back to your empty environment that you've just created, and you do conda install pandas, numpy, hrplot, holoviews, and xarray. Great. In an ideal world, would be done. Everything would run. There'd be no more things to worry about. Okay, but that's not quite as simple as that, because what would happen is you'd go down, and as soon as you hit, for example, the line that says import hrplot.dask, you'd hit a new error. And that's because you don't have Dask, and Dask is an optional dependency of hrplot. That means hrplot will support Dask if you have it, and if you don't have it, you can still use hrplot with other things, right? So now you have your optional dependencies. And if you were to run this, it would say module error, module not found, no module named Dask. Okay, if you run a little bit further, it would then complain about no module called intake. And if you read the exception, it would even say this sample data requires intake and intake parquet. Okay, so we have 3 new dependencies that we might want to add to our environment before we can get it running. Okay, so what you would then do is conda install dask intake and intake cut parquet. And one thing to note is, even though there's a hint that you need dask because of the import hrplot.dask, you'd also hit this issue on the line where you do data frame to dask persist. So point is, you're using dask, and it was an optional dependency of hrplot, but it would have been a non-optional dependency later on. Or it's actually implicit in the to-dask statement here. Okay, so you do that, you run it all again, you're getting a little tired of having to install this stuff, and then you get to the line about loading some sample data from this hrplot library. Okay, this is why you installed intake, but apparently it's not enough. You will then complain with a value error, which says, no plugin found for this entry xarray image. At this point, you need to have a little bit of special knowledge. You need to know this is because there's a plugin you need for intake called intake xarray. Okay, off you go back to your environment, install intake xarray. Are we done? Unfortunately, we are not done. Even though we get past this import line about importing this data set airline flights, we now have a different type of import error or dependency error, which is a dynamic one. It's not quite the same as an optional dependency. It's happening at runtime, and it's because the particular data format we're loading requires something called snappy compression. Now, it'll just tell you this sort of mode of decompression isn't available, and it'll tell you what's available, but what you want is snappy. Okay, so then you need to know that the correct library to install is called Python snappy. So off you go, conda install Python snappy. Are we done? Well, we're not. There's one last thing you need to do, and that is, when you're in this notebook, there is a keyword argument that we pass to this library hrplot called datashade equals true. What datashade equals true does is it uses a library called datashader to render a very large data set. It's very cool. I recommend you check it out. But it's something that is, again, a dynamic dependency. And the reason it's nested is because you don't know this because of all the previous errors you had. You've not been able to execute that far, so you've not been able to see that there would be an error until you reach it, try and execute it, and then you realize you don't have datashader. And that's what it says here. Import error, data shading not available. Okay, so now you do conda install datashader. So you can see that there's a lot of steps that were needed for someone who had no instruction and given a notebook that what they needed to execute in order to actually get everything running. Obviously, as an author of a notebook, you want it to be easy to run. You want people to very easily get your code and run it. So what do? Well, possibly the easiest thing to do is give the user instructions. You run it yourself from a blank environment, you figure out what's necessary, and then you tell the user to do it so they can skip all of this process of finding out what needs to be done. So you might tell them again to create a blank environment, activate it, and then give them a big long conda install command with everything that you found that is necessary. Finally, you need to tell them what command to run, and that'd be Jupyter Notebook. Okay, this is pretty verbose, and that's not even capturing everything, because it might work today, but if you try and execute this in 6 months' time, what chance is there that one of these libraries will have a new version, with a new API, something breaks? Well, it's really quite high, because this ecosystem is always changing. So what you really want to do is pin all of these. Now, if you give a pin command with conda install with all of these things, it's going to be really long, really ugly. So that's not a great suggestion. What you could do instead is create an environment YAML. This is fairly popular, and it is a better approach in many ways. What it is a file with all the packages and all the libraries all pinned that you can create a new environment from. Then you activate that environment, or you have it activated for you with a command, and then you run the notebook. But even then, it's not really ideal, because you now have this file, environment YAML, that you need to give to people along with the notebook or whatever other assets you have. You have this issue that the environment YAML specifies a name for the environment, and it has to be a unique name. If that name exists, you won't be able to do it. So what's going to happen? You're going to have a unique name, a unique conda environment for every project that you have. You might have hundreds of projects. You need hundreds of environments, each with unique names. It's a bit of a pain. The other thing is, this file can get stale. As you change the notebook, you might add some new dependencies, remove old ones. And if you don't keep testing it, then the environment YAML will not actually run the notebook that you have. So you need a way of trying to reproducibly start from scratch each time, as opposed to just having an environment YAML with an environment that you just activate. And finally, the command to actually run Jupyter, you still need to tell the users that. They might not know, and you might need to tell them exactly which notebook to run with Jupyter Notebook. So there's a couple of things that are still missing, even if you do have an environment YAML. So how about the approach that I showed at the start with this anaconda-project tool? Well, the first thing, which I already demoed, is just do conda install anaconda-project. And you don't need to be in a blank environment. You can be in any environment that already exists. The dependencies are very minimal, which means that it's actually going to install pretty much anywhere. There shouldn't be much trouble installing it. And once you've got that, you have a command called anaconda-project. Okay, so let's have a look at it. This is the example I just ran. And one thing I'll note is there's a new directory called env. I list it. It's got something called default in it, and that's my environment. So anaconda-project does not create global conda environments, avoiding this issue of namespace clash with naming. It just creates a new environment in the directory you're in where your project lives. And that's really convenient. So what happens is you get this new command called anaconda-project. You can, of course, use help. You can find all the different things you can do. One of the things you can do is call this command, which will tell you what you can run with it. Like what I just ran, there's actually two things you can run with this one. And it's all based on this file called anaconda-project YAML. And now I'm going to talk a little bit about this, and this is the full specification of a reproducible unit of work. Okay, so we've done actually most of the work already to figure out how to capture this exploring data notebook. We create this new YAML file, we give it a name, it's called exploring data. We have a description, which is nice because you can actually explain what it's all about in a sort of meaningful way to people. Then you specify things like your channels. Well, I don't use any special channels, but you might want to get your packages from conda-forge or somewhere else. You can always do that. And then just the packages. And these are just the packages that you'd have listed in that conda install command. Just add them all here. And to begin with, you don't need to pin them. Because right now, you just want to see if you can get an environment that works. And then you have your env specs, and that just specifies which environment you want, and it's called default, which is that directory I mentioned. You can actually have multiple environments in a single project. But the key point is you create this little env directory. Now, you can actually activate this. You can do conda activate envs default, right? Now what you have is an environment that you can run the notebook in, and you can then test whether everything works with the versions that it actually fetched, right? And to get to this point, I'll actually show you how to do that. So if I conda deactivate first, what you might not do initially is not a anaconda-project run command, but you can do a anaconda-project prepare, and that's just the environment step. So right now, nothing would happen because I already have an environments directory. Probably will tell me that. Nothing happened. But if I remove this directory, which will take a few seconds. It's quite a lot of packages in there. Once I've removed it, I run anaconda-project prepare, and that will just create the environment based on that specification with that list of packages that I put in this YAML file. And that's going to get me going, because then I can activate that directory, run the notebook, run it from top to bottom, make sure everything works. And when it does, I can actually find all the versions that I have or the packages that I listed from this list that Conda gave me. And then I'll have a reproducible set of packages that I can create. So that's really going to help you in many, many ways, because not only do you have something that's like an environment YAML, but you have this name, this description, and as you'll see, you'll also be able to encapsulate the commands that people need to run. That's the next step. So let's wait for it to be done. Okay, it looks like it's done. If we do ls, our env directory is back. So here we go. All our packages are now in that directory. Okay, so let's just say that I took this very simple cut of this file, this YAML file, added the pins that I just mentioned that I found from Conda when it successfully got all the versions that work. I can then do the next step, which is defining commands, and this is really nice. You might have a really long command line invocation to run a server with certain ports, with certain host names, God knows what. There's all sorts of things that you might want to have in there. It's really nice to be able to have a little target, like a make target, similar kind of idea, where you just say, anaconda-project run, a simple name, and it runs a long command. And here, in the file that I've got defined, I've got two commands that run notebooks. So now I can run anaconda-project run exploring, which runs my exploring data notebook, or anaconda-project run capturing, and that will run this capturing notebook, which is what you're looking at now. And if you just do anaconda-project run by itself, nothing else, it's just the first example here, you'll just do the first one. Just the first command will be executed. So now that I've actually done a prepare, I can actually do this. So now I have my little environment. I can do conda project list commands, which I already kind of showed you. I can then do run capturing, which is just going to be the same notebook you're looking at. It's not very interesting. It doesn't really have any dependencies. But there we go. Started up the notebook server and served me the notebook. So once I have that, I can actually put a little comment at the top of my file which tells users everything you need to know. Just conda install anaconda project. You can even pip install it and run anaconda project run. That's it. So you might be wondering, how is this really easily distributable? I mean, it's got this directory with all these files. Well, the trick is you can archive it, creating a single archive which will actually contain all the things you need, your data files, your notebooks, your assets, everything. And then you should give them that, they extract it, and that's kind of where I started this whole talk. How do you do that? Well, you can do a command called anaconda project archive. What that will do is create a little tar.gz file with everything except for the ems directory, because that would be a really huge thing to package, and you don't actually need it because you're going to recreate it with conda. So let's just say I do that, right? Now I've created a new archive which has everything in it, all the stuff I need, as you can see here, and it will be something that I can give to someone else and they can run Anaconda project run on. Finally, if you have an anaconda.org account, you can just type anaconda project upload. And what that does is it takes the packages and instead of it creates the archive as before and uploads it, which is exactly what I pointed to at the very beginning of this talk. This is my own Anaconda project username, Neil Stevens, and I have this section called projects, and my projects are all here. I've got all sorts of things, and one of them is now this exploring data project, which I can just point someone to, give them the URL, they can download it, and all they need to do now is Anaconda project run. So I hope that kind of illustrates some of the things you can do with Anaconda project. There's a lot more. As I said, not just notebooks, you can run Unix commands, so any arbitrary Unix command, any arbitrary Windows command. You can run a Flask server, some Django server, for example, or maybe a dashboard server. Voila, there's all sorts of different things you can do, which is all captured by this command, which then runs in the environment that you specified. So it's bundling the notebooks that you run, the code that you run, the data files that you need, which you might be loading. It can even actually download data off the internet for you as part of the Anaconda Project YAML, which I'm not talked about, but it's all in the docs, which you can find. You can set up environment variables, either from the command line or actually in the YAML file. You have a lot of flexibility to do a lot of different things in a way that's kind of encapsulated into a single archive. And that's really powerful. And it's something that I'd like people to consider next time they have this trouble of having a notebook and trying to give it to a colleague and getting them to run it, and having to tell them all the different dependencies and versions and commands and steps that they need to run to actually get it working. If you use Anaconda-project, you can capture a lot of that data into a single YAML file and have a much nicer, much easier workflow that you can just tell people, and if everything goes well, it'll just work. So I hope that was helpful. And if you haven't seen my other talk, which is exactly about hrplot and visualization, which is the notebook which is actually being distributed with this project, and I do encourage you to check it out if you're interested in visualization and, well, working with pandas, data frames, or X-arrays and visualizing the data. Other than that, I hope that my little talk about reproducing code and capturing that code has been helpful. And thank you very much for listening.